Today I will be introducing the Dijkstra algorithm using priority queue. Please recall breadth-first search, which gives us the shortest path from the start node to every other node given the graph is unweighted. Now, what if the graph is weighted? Apparently, a normal queue won't apply. So here's why we use the priority queue, which ensures that the shortest path is always pop out first, and then the longer path is pop out later. So to use the Dijkstra algorithm, we need the following attributes. For the node, we need the ladder, which is the identity, the shortest path during the search so far, denoted by S. It is initialized as 0 for the start node and infinity for every other node. And if this node is visited during the search. And for the edge, we need the weight W, we need the nodes it connects, and its directionality if the graph is directed. So here are the basic steps of the Dijkstra algorithm. First, we will push a tuple start 0 into the priority queue. While the priority queue is not empty, we will pop the first element, mark the current node as visited, and if its neighbor n is not visited, and the shortest path of the current node plus the weight of the edge is smaller than the shortest path of the neighbor, then we will add another tuple n s current plus w into the priority queue. And finally, we will update Sn equals to S current plus W. Now let's see how it works with this graph. First, we'll push A0 into the priority queue. And then while it's not empty, we'll pop it, mark it as visited, and add its neighbor into the priority queue. Since it's infinity, apparently they should be added. So C1 and B2. And mark this as visited. Now, since 1 is smaller than 2, we will first pop C1 and mark this as visited. And we will push a D5 into it and update its shortest path. And then, since 2 is smaller than 5, we will pop B2 and then mark it as visited. And its neighbor E, it has a 7. And for D, since 2 plus 2 is smaller than 5, we will have to push a D4 and update it to B4 and add a E7 here. Since 4 is smaller than 5, we will push D4 first. And then since the path to D is 4 plus 5 equals to 9 is smaller than 7, we won't be pushing an E9 into the priority queue. And after that, we will only have D5, which is already visited, and an E7. And finally, when it's popped out, we can know that from A to every other node, what is the shortest path. Now, if you want to backtrack, we can add another attribute to the node, which is the previous node of it, so that we can trace it and know what is the shortest path exactly instead of knowing only the shortest path value. Know that the Dijkstra algorithm only works for a non-negative weighted graph. If some of the edges are negative, we could not use the Dijkstra algorithm. Thank you.